object located in the scattered disk beyond the orbit of Neptune. This object is considered to be a strong candidate for dwarf planet status due to the fact that it is a pretty significant size, possibly measuring around 760 miles, 1,230 kilometers in diameter. Gonggong is also believed to be massive enough to assume hydrostatic equilibrium, a requirement for dwarf planet status. Size comparison. Gonggong is pretty large for a dwarf planet candidate, having an estimated diameter of 760 miles, 1,230 kilometers. So it is roughly the same size as Pluto's largest moon Charon, and it's also the fifth largest known TNO, only after Makemake, Haumea, Eris, and Pluto. Surprisingly, this object is theoretically 1/10th the diameter of Earth, slightly larger than Makemake, and is even 1/3rd the size of the Earth's moon Luna, which is also about 2,159 miles, 3,474 kilometers in diameter. Time. Gonggong takes 554 Earth years to complete a single orbit around its host star. The rotational speed of the candidate is 22.4 hours, being unusual for its own size, but is most likely slower due to the presence of its moon. The location of the dwarf planet candidate is in the Kuiper belt, in a 310 orbital resonance with Neptune. Discovery. Gonggong got its name in 2019 through a public poll, after a Chinese water god of mythological deity as an honor, since it's characterized by a reddish surface with frozen water and some organic complex compounds, especially tholins, and also has a slow rotation that is impacted by its own satellite Xiangliu. The candidate was discovered in July of 2007 by astronomers Megan Schwam, Michael E. Brown, and David Rabinowitz. Planetary structure. Gonggong is a large icy methane body of solid rock in the outer solar system, producing valuable insights into the creation and evolution of these particular distant objects. The bright red color that is caused by the tholins presented on its surface, and gives clues about the chemistry and geological processes that happen inside the Kuiper belt. It likely consists of a core, mantle, and an icy crust, which is similar to all of the dwarf planets including Pluto. It has a slightly oblate spheroid shape, and the internal structure was expected to have undergone differentiation, which is separation of heavier elements to core, and lighter to the surface, with possible internal melting, which proposes a layered structure, core, mantle, and icy crust. Gonggong also has an atmosphere that possesses a very thin, tenuous structure of methane, CH4, which slowly escapes into outer space. The object has a very large moon named Xiangliu, with a diameter of around 62 miles, 100 kilometers. The presence of the moon hints a theory about a violent collision event, which had eventually formed it. Overall, Gonggong has a cold and complex world structure covered mostly in ice, with a possible internal structure that is similar to that of the major dwarf planets including Ceres and Pluto. However, has a unique range of characteristics like the slow rotation caused by its moon and the reddish coloration from the tholins that are on its surface. Gonggong may also experience internal water eruptions on its surface, which is explained by the process of cryovolcanism. Early history formation. Gonggong was formed just around the same time as the other objects in the solar system, which is approximately 4.54 billion years ago, while the object stripped ice, methane, dust, and other debris left in the orbital scattered disk surrounding the young sun. The moon Xiangliu was formed after a large-sized object invaded Gonggong's Roche limit, and then collided with it, causing itself to crash down into multiple smaller pieces, which then eventually got reshaped and reformed by gravity in order to create a satellite for Gonggong. And after the formation of Xiangliu, the rotation of the candidate extended. Gonggong acquired tholins on its surface through the irradiation of methane, as well as other simple organic molecules by solar radiation and cosmic rays. Then the energy broke down the simple molecules and initiated more complex chemical reactions that produced larger, reddish organic compounds that are known as tholins. The reddish tholins present are a type of brownish-red, tar-like substance that cover the icy surface of this candidate, giving the object its distinctive red color. This process is even observed and found on other distant solar system surfaces including Pluto's or Titan's.